Let's talk about how we can extend the trigonometric functions to angles of any size. In an earlier video, I talked about how we can define trigonometric functions for acute angles. An acute angle is between 0 and 90 degrees, and any acute angle describes a right triangle that has a specific shape. And the trigonometric functions are built by taking ratios of the side lengths of that right triangle. We can think of one side as being opposite the angle theta, one side adjacent, and the hypotenuse. But for angles that aren't between 0 and 90 degrees, it becomes harder to kind of think about. We can't really think about it in the same way. For example, a 120 degree angle cannot be placed into this setting. But it would be nice to have a similar way to define trigonometric functions, to have some way to define trigonometric functions for other angles like 90 degrees. And we can, right? We can do that in the following way. We can think of angles as representing rotations. So we can think of this 120 degree angle as representing a certain amount of rotation that it takes for the one side of the angle to reach the other side. So think of this maybe as a door opening or a hinge, where here at the corner the hinge bends and opens up to create that certain amount of rotation. With that perspective, we can define something called the standard position of an angle. The standard position places an angle on the coordinate plane, the xy coordinate plane, in the following way. So we have an x-axis and a y-axis. I'm going to identify one side of an angle with the positive x-axis. And this is called the initial side. And then, depending on the size of the angle, for a 120 degree angle, we can kind of rotate in a counterclockwise direction until we get to an angle of that size. And when we do, we'll stop. And the other side is called the terminal side. Of course, the corner of the angle, we can still think of that as the vertex. So the vertex is placed on the origin. One side, called the initial side, is placed on the positive x-axis, and then, depending on the amount of rotation described by that angle, the other side appears somewhere in the coordinate plane and is called the terminal side. So this allows us to do a couple kind of cool things. We can think of positive and negative angles. A positive angle is associated with a counterclockwise rotation, and a negative angle is associated with a clockwise rotation. So let's look at an example of those two. Let's say we have an angle of 50 degrees, and well, let's say it's a negative angle of 50 degrees. So I'm going to start with the initial side in the same place. The initial side is always on the positive x-axis. One side of the angle is always on the positive x-axis. And then if I rotate in a negative direction, I'm going to go clockwise, and let's say we go clockwise 50 degrees. So it's a little bit more than halfway to the y-axis, and this is a negative 50 degrees. That's the same, that terminal side, the terminal side would be the same. We'd end up at the same place if I went in a positive direction. How far? How far would we have to go in a clockwise direction to get to that same position? Well, I hope you're familiar with the idea that a full circle is 360 degrees. So to get almost the full way around but we're kind of missing the last 50 degrees, that means we went 310 degrees. What this means, an important sort of notion here with our new setup, is we can talk about coterminal angles. And from what I just described, we would say that 310 degrees and negative 50 degrees are coterminal, which simply means that their terminal sides end up in the same place. Their terminal sides are in the same location. So with this notion of terminal angles, let's take a moment and think about a couple questions. So one question that comes up is the idea of, suppose we have an angle, we're interested in an angle of 900 degrees, or maybe we're interested in an angle of negative 75 degrees. For both of those angles, they're outside of kind of a normal sort of positive rotation from 0 to 360, so we might want to find the smallest positive angle that is coterminal to them. So we want to find the smallest positive angle that is coterminal to the given angle. Well, because 360 degrees represents a full rotation, if we add or subtract 360 degrees, we'll get back to the same place. We'll get to a coterminal point. So we can either add or subtract 360 degrees. So for 900 degrees, if we subtract 360, well, we can take one 360 away from that, and hopefully my math is okay here. I think we end up with 540 degrees. But that's still bigger than 360, so it's not going to be the smallest positive angle that's coterminal to it. I can take away another 360, and we end up with, let's see, so if I add 40 to that, I get 400, and then 180, I guess, right? So a 900 degree angle is coterminal to 180 degrees. 900 degrees means that we go 2 full rotations in a positive direction, then plus 180 degrees more. So that would be a 900 degree rotation. 75 in a similar way, but a little bit simpler, we can take negative 75 to get a positive angle. I can add 360 to that. So we end up with 285. And thinking about that in a diagram, negative 75 would be similar to negative 50. It's down, the terminal side is in the 4th quadrant, and we can get to that same spot by a positive rotation of 285 degrees. So coterminal angles, the idea of coterminal angles is pretty important, and we'll see when we define the trigonometric ratios that coterminal angles will lead to the same trigonometric ratios. Angles are often described by where their terminal side lies. And what I mean by where, I guess I should be a little more specific here, by the quadrant in which their terminal side lies. A quick note on quadrants in a coordinate plane. The first quadrant is where x and y are both positive. The second quadrant is where x is negative but y is positive. The third quadrant is where both x and y are negative. And the fourth quadrant is where x is positive but y is negative. So we could talk about with what we started with the 120-degree angle. The 120-degree angle, it's bigger than 90 degrees, but it's smaller than 180 degrees. And so we could talk about that as having a terminal side in quadrant 2. In a similar way, 285 degrees, and likewise, because it's coterminal, negative 75 degrees as well, have their terminal side in quadrant 4. Because 270 degrees would be the negative, it corresponds to the negative the negative y-axis. 285 is a little bit bigger than that, and so we would say 285 has its terminal side in quadrant 4. And again, we'll see that the reason why I'm bringing this up is because it does relate to some characteristics of the trigonometric functions that we'll talk about in a moment. It is often useful to be able to identify angles with a specific quadrant. When the terminal side of an angle falls on an axis, like is true for 90 degrees and 180 degrees and 270 degrees, that's a special situation because it's not really in a particular quadrant, it's sort of on the border between two. So these are called quadrantal angles because they are the borders between a pair of quadrants. One last comment on terminology. I spoke earlier about complementary, in a previous video, about complementary angles. Complementary angles are two angles that add up to 90 degrees. So for example, we could take 35 degrees and 55 degrees would be a complementary pair. In discussions to come, the idea of supplementary angles are also important. Supplementary angles add up to 180 degrees. So for example, we could take 120 degrees and 60 degrees would be a supplementary pair. Geometrically, 180 degrees can be thought of kind of as a straight line. So if this is 120 degrees, this would be 60 degrees. Complementary angles add up to a right angle. So if I take 35 and 55, they would split up a 90-degree right angle. From what you've seen in the video, please take a moment and think about the following question. For the angle negative 510 degrees, take a moment, make a sketch of that in the coordinate plane. So sketch that angle in standard position. And also think about the smallest positive angle that is coterminal to that. And there are actually an infinite number of angles coterminal to any given angle, so try to think about some others that would also be coterminal. A second question: what angle is supplementary to 135 degrees? Thanks for watching.